One more funny item to talk about. The TV show Impact, a two-parter that was on this last two Sundays. Oh my, I think this is, at least in the running on the short list, if not the worst abuse of science in a TV drama ever. It was horrible.
It was, yeah.
Yeah, it could have been better.
I mean, there were there's like so many things to talk about. It's like we have to pick and choose the most horrible things to talk about.
Right.
We could spend 2 hours dissecting it.
I mean, Nastasia Henstridge is in it, and she's pretty cool. I actually like her.
Yeah. She's holding up pretty well.
Some people would say, yeah, she's really pretty. Fine. I've actually liked the stuff I've seen her in. Do you ever see She Spies? I still stand by that show, the first season at least. It was a satire on spy shows, and it was hysterical. And she was really funny in it. But yeah, she stars as an astrophysicist. And basically, I only saw the first part. I've not seen the second part. Not gonna, all right, just to let you know. But there's the biggest meteor shower in 10,000 years, and so everybody's out looking at this meteor shower. And then they suddenly discover a giant piece of debris or something that's huge. It's miles across, and it slams into the moon. And it creates an explosion, and then pieces of the moon fall down and hit the Earth. I was actually rather surprised. The opening of the show, besides making sort of the standard mistakes of two people sitting next to the telescope in a brightly lit room, you kind of want it dark where your telescope is so that light doesn't get in and destroy what you're trying to take pictures of, right. and instantaneous access to video from space and things like that. It makes a lot of those dumb mistakes, but the rest of it wasn't awful. The meteor shower was depicted fairly well, and on that other stuff was okay. But this thing slams into the moon. It creates a huge explosion. Stuff brains to the Earth. And then they find out that these impacts were much bigger than they should have been. They discover one crater that's like 20 feet across, but the meteorite in the bottom of it is only like 3 inches across, the size of a baseball, something like that. And it turns out it's this uber-dense material. It's uber-dense. There you go, just for you guys. And it turns out that the moon's orbit changes. And I was reading this, or I was watching this, thinking, the kind of impact it would take to change the moon's orbit would vaporize the moon. It's just a huge amount of energy you'd have to dump into the moon, so much so that it would make half the moon would be destroyed. But it turns out that that wasn't as bad as I thought, because what the moon got hit with was this giant, super dense material. Now, this part made me cringe. They called it a brown dwarf. They said it's a brown dwarf material. And I thought, no. And then this guy's astronomy student, I don't know if she was a grad student or an undergrad, but she says, what's a brown dwarf? And I thought, really? Really you don't know what a brown dwarf is and you're an astronomy student? But
it's a poop.
It's a brown dwarf is an object that's like a somewhere between a planet and a star. It's like if you took 10 Jupiters and smashed them together, that would be a brown dwarf. And so it's a giant gaseous object. You can't really get a chunk of it. And then they started describing it, and the guy said, well, it's what's left over after a star, like the sun evolves, blah, blah, blah. And I thought, oh, it's a white dwarf. They just got their colors mixed up. And so they just used the wrong object, which was painful to listen to. But what's funny is you can't have a chunk of a white dwarf. The reason a white dwarf is so dense is because of its gravity.
Exactly.
If you stood on the surface and took a shovel and picked up a piece of this stuff, it would explode, because all that's holding it together is its own gravity. And if the chunk is too small, it won't have that gravity to hold itself together, and it would explode. It would be like it would be an explosion. That's the best way to describe it. So you can't have a piece of this stuff hitting the moon. But even if you could, after that, their science was confused. They got some of it right. The moon's orbit would change. Basically, enough of this stuff hit the moon that it got so much more massive. It actually had twice the mass of the Earth.
Yeah, so hang on. So that's where I think that one of the biggest problems is, though. So first of all, if you have a small object, if we take their premise, which, as you say, is absurd, where you have a small object that's twice the mass of the Earth smacking into the moon, the heavier objects, momentum is going to predominate, over the lighter object. The way they had it, the moon's orbit initially didn't change at all, and then it just sort of suddenly changed a little bit. Then it started changing. Now, I would think that thing would almost go through the moon, and if somehow it didn't go all the way through the moon, it would have radically changed the moon's orbit. Well, in fact, the Earth would have been orbiting around it more than it was orbiting around the Earth, right?
So that's right.
The Barry Center would change.
The Barry Center between the Earth and then there's now 2+ Earth masses would have been closer to that object than to the Earth.
Right.
That's exactly right, and that was why I was laughing through the rest of the movie as I was basically fast-forwarding through it. I hadn't thought about the fact that it might pass through the Earth, or pass through the moon, right until just before you said it. And I was opening my mouth to say, this stuff is so dense.
Yeah.
It might the moon would be like a vacuum, and it might pass right through, especially at interstellar speeds. This thing would have to be moving at huge speeds, and I'm talking about 100 miles per second or faster. And it's so dense, it might very well have passed right through the moon. But let's just say that it didn't, and the moon somehow were able to suddenly be twice as massive as the Earth. You would notice this right away. Basically, because the Earth would start orbiting the moon instead of vice versa, the sun would not make a simple arc in the sky. It would make all these crazy loops as the Earth was spinning and going around the moon at the same time. So they really screwed that up. It's not like it would be days later and people would be scratching their heads saying, what's going on with the moon? They'd be freaking out and saying, what's going on with the sun? As the Earth is going, all around the moon. Yeah, they kind of screwed that up. And then there were all kinds of crazy electromagnetic effects that wouldn't happen. Magnetic effects. This thing has a super strong magnetic field, and you see like a maglev train flying off into the air and people floating up. And it was, at that point, it was just, flip the crazy, stupid science switch in the movie script, and it went totally off the rails at that point. I have no desire to see the second half because of that.
Yeah, there's like these local anomalies in gravity because of this thing. So people were just floating away. That was bizarre.
Yeah, the quote, I wrote down the quote, the one that really struck me. If the EM energy is powerful enough, it will override local gravity.
Yeah.
Okay.
Yeah, that's just...
That's also known as turning on a flashlight. If you can't point a flashlight down and go rocketing off into the atmosphere, I don't think this is going to work either. In fact, if you were to take an object like the moon at its distance and give it so much more mass, basically the moon is an 80th of the Earth's mass. So basically you're multiplying its mass by 160 to give it twice as much mass as the Earth. The tidal effects on the Earth would be so severe. They would be 100 times greater, 200 times greater than they are now. There would be tsunamis and huge amounts of flooding. There would literally be tidal waves. And so you'd see like Indonesia would be wiped out and coastal cities would be flooded because instead of getting your normal 2 or 3 foot tides, you'd be getting 100-foot tide. That's maybe something somebody would notice. They mention the tides and say, ooh, it's getting bad. But, they, as typical with these sort of disaster movies, they grossly underestimate just how bad these things would be.
It gives the term disaster movie a whole new meaning.
But yeah, you're right. They glossed over the tides, and then it's worse than just that the moon now, as you said, it's 180 times or 160 times the mass that it was. It also came a lot closer to the Earth eventually on the show. So, the tides would have been massive. It would have been scouring almost every tidal waves would have been scouring just about every place on Earth.
That's true. The size of the tides depends on the mass of the object. So if you add 160 moons to the moon, you have 160 times the tidal force on the Earth. But in fact, the distance is a much stronger force. It goes as the cube of the distance, or actually the inverse cube. So if you put the moon twice as close, half the distance it is now, the tidal force will actually be 8 times as much. And if it's 5 times closer, the tidal force will be 125 times as much. 5 times 5 times 5 times 5 times 5. There you go.